How's it going, everybody? Now this video is going to be about building a data warehouse, and we'll cover the technical details and the theory, but I'm going to do something a little different. You see, I'm going to tell you the story of an actual implementation, but not just any implementation. This was the most challenging project of my career. Now this is a project where I served as both project manager and lead architect. So by the end of this video, you'll have a good idea of what it takes to build a data warehouse. So let's go.
Now let's start off by giving you a little bit of background about the company I work for. Now the main goal of the organization is to achieve growth through acquisition, which basically just means they buy other companies or brands and look to run them. And so I don't work for these individual brands directly, but rather through an operating company. So each time a new brand is acquired, the operating company's job would be to integrate the systems and run the day-to-day business. Now let's take a closer look. Now, as you might expect, my job is to oversee the BI data warehouse environment for all the brands. And when a new brand is acquired, it would be my job to analyze and consolidate the new brand's environment into our existing environment. Now, this type of work is rewarding, but also challenging, as you have to consider data, applications, and not to mention the users that depend on these systems to do their jobs. And it's particularly challenging when it comes to BI, because BI typically touches every department in an organization. And a lot of times you'll have many different data sources to consider, and more times than not, an organization will have more than one BI or reporting solution, and it may not necessarily be something you're familiar with. So with this type of work, you're constantly getting exposed to different technology, new and old. Now, it's also important to note that certain acquisitions can come with hard deadlines, and failure to meet these deadlines can cost the company big money. So you want to make sure your project is wrapped up on time.
And that was the case with this project. See, we just acquired a new brand. However, this brand was owned by another company. And typically in this case, there'll be an agreement in place that states that you have a certain amount of time to transition the company out of their environment and onto your environment. And I guess you could say this was the first challenge, time. Now, this was a large company, and chances are if you live in the US, you've heard of them. But see, they didn't have a true enterprise data warehouse or BI solution. So now, let's take a look at where the story really begins.
I guess you can say this story really begins when I receive an email from the newly acquired organization's CIO. Now, attached to this email was a document, and this document provided a high-level overview of their current BI environment. Now, upon reviewing this document, a couple of things stood out. One of which was this environment wasn't supported by IT. Rather, it was a legacy environment that was built by business users. And it started out as a small access database that, over the course of 20 years, had grown to over 100 access databases. The other thing that stood out was how they get the data into these databases. See, they didn't have any ETL software to handle data transfers. So all the data was downloaded from the host systems manually and loaded into these set of 100 access databases manually. Now this process took them over 2 hours to complete every single day, and that's if they didn't encounter any issues. Now, where am I going with all this? I thought we were building a data warehouse, right? Well, just because you acquire a new company and they don't necessarily have a true enterprise data warehouse, that doesn't necessarily mean that you go ahead and build one from the ground up as part of the initial transition, especially with a deadline looming. And so my first order of business was to evaluate their existing environment and see if we can support that going forward so we don't interrupt the day-to-day operations of the business, until we eventually get around to building them a true enterprise data warehouse. So I flew to where the team that supported this environment was located. Now this is where I start to get a better idea of what it would take to support this environment going forward. And this is where I learned that these databases had dependencies with each other and also spreadsheets located on various file servers. Now this meant that transplanting these databases from one environment to another was not going to be easy. Now the other thing is that they encountered issues with this manual process they were using to load these databases 2 out of the 5 days I was there. Now this required extensive research, and so the 2 hours that this normally would took to do took more like 4 or 5 hours. Now this was if you knew what you were doing. Now the other thing with these types of situations is there's some staff that you inherit and some staff you don't. And this particular team was not going to be coming forward with us, which meant this proprietary knowledge that they had about this environment was going to be lost, and it was going to be up to my team to support this going forward. Now, my other major concern was accuracy. See, the entire organization depended on this data to run the business and make decisions. And with such an unstable environment, I feared that we ran the risk of potentially giving the business incorrect data. And I worried that this could mean that my team would be endlessly scrambling trying to support this environment and resolve data issues. Now, this could also mean reduced productivity for the entire department. And since we had other brands to support, this could also start affecting them as well. Now, these were all very real risks in my mind. And so at this point, I was faced with a difficult decision. Do I accept these risks, or do I attempt the impossible and attempt to build a data warehouse from the ground up in record time? Now, when you add up frequent failures, loss of proprietary knowledge, accuracy issues, lost productivity, and the fact that we were eventually planning on building them a data warehouse anyway, I decided to build a data warehouse. But that begs the question, what is a data warehouse? Now, we can't talk about building a data warehouse without first defining what it is. And I think the best way to do that is to compare it to your regular application database. Now, the job of an application database is to store application data. And this could be anything from a financial application to a warehouse management system that runs a warehouse, for example. Now, these are the databases that most people are familiar with and interact with on a day-to-day basis. And the goal of this type of database is typically to store and process some type of transactional data. And so the structure or design of the database would be centered around the application itself. And it would be based on doing whatever the application was built to do. Now, typically these applications will come with some level of reporting, but the databases are really designed for the application, not necessarily for analytics. And so this can make querying the data challenging and time-consuming if you're trying to perform complex analysis. But that brings us to the data warehouse, where you see the goal of the data warehouse is to give the business the ability to better analyze their application data. Now, a data warehouse does this by consolidating all of the organization's application data into a single database that's geared for analytics. But what does that really mean? See, the reason a data warehouse provides such analytical advantages is because it doesn't just take the source application data as is. Instead, the data is modified or transformed into a new structure or schema in the data warehouse. Let me show you what I mean. Now, suppose we're a company that has store locations and an e-com business. Well, an application might store transactions related to these different channels in separate tables. Now, this might be because they're handled completely differently within the application. Now, that's fine from the application's point of view, but what if we wanted to analyze these transactions? See, from a business point of view, maybe e-com is just considered another store. And so, analytically, there really is no difference between these two channels. And so, in the data warehouse, the structure of this data might be completely different, where both store and e-com data live within a single table. So now you can see that adding data to a data warehouse requires a lot of work up front as you design the new structure and build all the processes that will ultimately transform the source data into the new structure. Now, this is just a high-level example, and we'll get into more detail later on, but the truth of the matter is that building a data warehouse requires a lot of analysis and design work up front. It's not just as simple as loading raw data into a database.
Now, at this point, you should have a good high-level understanding about what data warehousing is all about, and there really is a design process that has to take place up front. So now we're going to take a closer look at that design process. So now next, we're going to take a look at the star and snowflake schema, as these are the two most common types of data warehousing schemas you'll find.
Now, when it comes to data warehousing, you need to change your thinking a little bit. And you need to start looking at things in terms of dimensions, which are really nothing more than categories of data. So let's think about a typical retail company, where over time, they sell their products at stores. And so the core dimensions would be product, as they might want to determine which products are profitable or not. And they also might want to determine which stores are profitable. Now, typically stores can be grouped into districts or regions based on geography, which would be another dimension, geography. Now, last but definitely not least would be time, as your company might want to analyze their company performance year over year, week over week, and so on. So these would typically be your 3 core dimensions in a typical retail company. Now, this process of designing a data warehouse is called dimensional modeling. But before you can begin this process of dimensional modeling, you're first going to want to decide on a schema type. And as I said, the 2 most common schema types are the star and snowflake schema. But first, let's take a closer look at the star schema. Now in a star schema, you'll have a single table per dimension. So our 3 core dimensions of time, geography, and product might look like this, where we have a single table per dimension, and our time dimensional table might have date, month, quarter, and year, and geography might have store, district, and region, and our product dimensional table might have SKU, subcategory, and category. These would be your typical dimensional tables. Now the other type of table are fact tables, and these contain facts, or the data that the business wants to analyze. Now some of the benefits of a star schema is that it has a simple design, which can make querying easier as there's only a single table per dimension. Now this means that it's also denormalized, which will produce less joins. Less tables, hence less joins. And less joins often means better performance. Now one of the downsides to a star schema is that it's not very flexible, and we'll see why when we take a look at the snowflake schema, which is what we're going to take a look at next. Now in a snowflake schema, you would have a lookup table for each attribute. So in the case of our time dimension, our date, month, quarter, and year would each have their own lookup table. Now as you can see, this type of schema will typically produce more joins. For example, let's suppose we wanted to aggregate the data from our fact sales table to the year. Well, we would first have to join our fact table to our date table on date to get the month. Then we'd have to join our date table to the month table to get the quarter, and then the month table to the quarter table to get the year. And then finally we can aggregate on year. Now the other thing to consider with a snowflake schema is the degree of normalization. Now this type of example is a fully normalized schema because each lookup table only contains the minimum amount of information necessary. For example, our date table only contains the month ID, so it only contains the ID of the immediate parent. And if we want to join to each level in the hierarchy, we have to join through each of the lookup tables in order to get there. Now let's take a look at what a hierarchy might look like using a moderately normalized schema. So here we have our geographical hierarchy, and we have our 3 lookup tables, store, district, and region. But you'll notice that each lookup table contains not only the ID of the immediate parent, but also the parent IDs of all the levels above. For example, our store lookup table not only contains the district ID, but it also contains the region ID as well. So as you can see, this moderately normalized schema will produce fewer joins. For example, if we wanted to aggregate our fact table to the region level, well then we would simply join our fact table to our store table to get the region, and then we can join directly to our region table from our store table, skipping district. This is because we already have the region ID in our store lookup table. Now the last type of schema is your fully denormalized schema. And the only difference here is that each table would also contain the descriptions. Now some of the drawbacks to the snowflake schema is that it's more complex, and there are more tables to work with. However, this also makes it more flexible, as having an individual table per attribute gives you the ability to use things like aggregate tables. So that's why this is my preferred schema.
Now, after you've settled on a schema type, you might think that you should start looking at tables and deciding which tables you want to bring to the data warehouse, but the truth is, you're going to want to look at this in terms of business process, and really you want to decide which business process the data warehouse is going to cover. Remember, this is about analytics and giving the business the ability to analyze their data. So you want to look at this from the business point of view, and then you want to decide which tables you need to facilitate that analysis. For example, maybe you want to cover sales or warehouse processing. So in that case, you would want to identify the data sources, and maybe it's point of sale data or data from your warehouse management system. Now after you've settled on a business process and isolated the data sources, you're going to want to clearly define the granularity. Let me show you what I mean.
Now let's suppose we've decided that we want our data warehouse to cover the company's sales. So for that, we might use point of sale data. And the source data may have a table just like this. Now this may be raw transaction data. So you'll notice the two columns transaction number and line number. That means this table is pretty much at the lowest level you can find, which means each record in this table represents a particular item that a customer bought in a specific transaction. This is pretty granular, and you may not want to bring in all this data into the data warehouse, because this might be too much data and it could impact performance. And you may not necessarily need to analyze data down to the transaction level that often. And so if your main goal is to report on store performance or product performance or company performance, you may want to summarize this information in the data warehouse. And this is important because you don't want your queries to be bogged down by this low-level transactional data every time they run, especially if they're not utilizing this level of information. And so maybe upon loading this data into the data warehouse, we aggregate the quantity to the store, day, SKU level. And so our new table in the data warehouse might look something like you see here. And you also want to make sure you identify the facts that you're going to bring into the data warehouse. Here we have a single fact, quantity, but in most cases you would have many others. So now with our new data warehouse table, store day item sales, we have improved query performance while still being able to support our analysis. This is also why I prefer the snowflake schema, because it gives us the flexibility to aggregate fact data to any level we choose. Hopefully now you have some idea as to how to define the granularity of your data warehouse and why it's an important step in the design process.
Now look, I'd love to tell you that I went about this by the book and spent months agonizing over every little decision, but the truth is, I just didn't have that kind of time.
Now before I get into how I did it, let's first review what needs to be done. First, I need to identify and analyze the source data. Next, I need to design a new enterprise data warehouse. Now this is one of the biggest challenges. See, the Access databases actually did a lot of data manipulation and formulas. So they were deriving a lot of new fields that didn't technically exist in the raw source data. So I have to make sure my new data warehouse design can cover this. Now this often meant reverse engineering complex Access queries. Now the next step would be to create the ETL logic. After all, once you have your new data warehouse design, you then have to transform the source data into the new design. Now we did have a team that handled ETL, but I was short on time, so I personally took this step on as well. Now once we had our new data warehouse, we then had to rebuild the existing reports. Then, after all the development is complete, we have to test and validate everything. Then last but not least, we need to train the users on the new system. So here's how I did it. See, I broke everything down into chunks based on business process first. Then I would tackle everything a chunk at a time. So let's say first I decided to tackle sales. Well, then I would identify all the source systems and the people that had expertise in that area. And I would have meetings centered around knowledge transfer and learning about the source data. Then I would design my new data warehouse for this chunk and write all the ETL logic to transform the source data into the new structure. Now, in order to speed up this step, I initially built the entire data warehouse using nothing but database views. See, it was common for our ETL jobs to stage the raw source data anyway, which means I had all the raw tables in a staging area in the data warehouse. This meant I could easily build views on top of that to serve as the new data warehouse design initially. Now this meant if I had any issues found during testing, I could quickly respond by just changing the query in the view. Now you never want to do this in a production data warehouse because views are slow and you will run into performance issues. But I knew that this work would not be wasted because once everything was validated, the ETL team could step in and use the queries in my views to build the physical data warehouse tables. This made their job easy and much faster. Now this approach saved everybody time. Now once I had the views in place, I would notify my team that they can start working on converting the reports that use this information. Meanwhile, while they were working on converting the reports, I would move on to the next chunk. See, taking this approach was important because it allowed tasks to go on in parallel. And it was also important because it allowed us to get the users involved in the process early on. which is critical because we were able to run our new environment in parallel with their existing environment, making validation easier while giving users more time to adjust, thus easing the transition. Ultimately, I had complete confidence with this approach because I knew my team, and I had a superstar developer that could take the lead on converting the reports, and we'd also made a recent addition to the team who was great at working with the business. So I knew she would be able to take the lead on transitioning the users.
Now this project started out feeling like my back was against the wall, but at the end of the day, it was a complete success. What made this project successful was involving the business users early on and making them feel like they were a part of the project and not getting the short end of the stick. See, you can build the best system in the world, but if the users don't buy in, it's not going to matter. And you run the risk of them having a bad experience and telling their boss who tells their boss, and before you know it, the project's been painted in a bad light, and no matter what you do, it's not going to be successful. The other thing was knowing where I can bend the rules to save time. The last thing that made this project successful was having a versatile team and being able to leverage their strengths where each person played a role. And that's how you build a data warehouse.
Thanks so much for watching. I really hope you enjoyed that. And please don't forget to like, subscribe, and hit the bell.